Okay, so this time we will discuss isothermal process. Okay, so when we talk about isothermal process, the assumption, unlike before when we talk about isometric process, the assumption is that the volume is constant. When we are dealing with isobaric, the pressure is constant, and when we are talking about isothermal, the temperature remains constant. Okay, so here, as you can see, we can start first with our combined gas law. Okay, so in combined gas law, this P1 V1 T1 is equal to P2 V2 T2. So if we talk about temperature is constant, we can eliminate temperature in our equation, simply leaving us with P1. So that is P1 V1 is equal to P2 P2. Okay, so if we perform separation of variables, we will have P2 over P1 is equal to V1 over V2. Okay, so just cross multiply. So this is your first equation for an isothermal process. Okay, next, letter B. So same as before, we have the change in enthalpy or change in internal energy muna. Okay, this is mCp dt. Okay, so since this is an isothermal process wherein there are no changes in the temperature, we can assume that dt is equal to 0, leaving us with the whole term of your internal energy to be equal to 0. Okay, this is principle number 2. Same goes with your enthalpy. So this one should be CV. Sorry, so this one is CV. Okay, enthalpy should be Cp dt. Okay, so this one will be equal to 0. So delta H during isothermal process is equal to 0. So what about the heat? So since this is an isothermal process, we need to introduce you to another equation, which is the heat source is equal to the sum of the internal energy plus your non-flow work. But our assumption before, so this is number 3, that the internal energy is 0, therefore this one is 0. So in an isothermal process, the non-flow work is equal to your heat. Okay, so this is number 4. Next, for letter E. So letter E. So the change in so the non-flow work muna. Okay, so let's start with the non-flow work. Okay, so this is P dV. So as you can see here, from bullet A, this one, so we can rewrite that as PV is equal to C. Okay, so by solving P in this equation, we will have, so divide both sides by V. So we will eliminate V on the left side. We will have P is equal to C over V. So let's substitute this one to that equation. So we will have the non-flow work is equal to integral of C over V dV, and C, we will remove it inside the integral sign. We will have the non-flow work is equal to C integral of dV over V from point 1 to point 2. So therefore, the non-flow work, so we've said that C is equal to PV. Okay, so this is P1 V1 natural logarithm of V2 over V1. Okay, so we just expanded the equation. So this is equation number, or principle number 5. Okay, next, the last one is the change in entropy. Okay, so for the change in entropy, we have integral of dq over t. However, we've said that dq is already your change in it is already your non-flow work. Okay, so therefore we can rewrite this one as, so dq, so derivative and antiderivative will cancel out, leaving us with delta S is equal to Q over T, or Q is your non-flow work over T. Okay, so change in entropy is the non-flow work over T. So this is equation number 6. Okay, so what about the steady flow work? So for the steady flow work, so that is number ano na. So this is E, this is F, so letter G. So the steady flow work is given by negative V dP. So we said that the relationship can also be written as this one. So we can rewrite V, isolate V by dividing both sides by P. So we have V is equal to C over P. Let's substitute it in the V in the equation. We have negative C over P dP, and then remove it inside the integral sign. We have negative C integral of dP over P, so for 0.1 to 0.2. Then the steady flow work is equal to C, that is negative P1 V1 ln of P2 over P1. Okay, so as you can notice here, P2 over P1, so from our early equation, P2 over P1 is equal to V1 over V2. So we can simplify this further. We can so this is also valid as your steady flow equation, but we can also rewrite this one as your negative P1 V1 ln V1 over V2. So if you want to reciprocate this one, let's say you want V2 on the numerator and V1 on the denominator, you need to get the inverse of this one. That will be negative P1 V1 minus ln V2 over V1. So this minus sign will become positive, so leaving us with the steady flow work is equal to P1 V1 ln V2 over V1. So simply means that your steady flow work, as you can see here, your steady flow work is also equal to your non-flow work. So we can write it here. So the steady flow work can also be equal to your non-flow work. Okay? So in the next video, let's try to perform or to answer problems relating to isothermal processes. So I hope you learned something basically in the theories and derivations of equation regarding isothermal process. Okay, so this is an isothermal process. So see you in the next video and have a nice day.